and forces, share the energy and information, maintain spinal neural integrity, help prevent against injury, and help it evolve to higher levels of organization and coherency that we see with network. First, we see the passive subsystem. That's composed of vertebra, ligaments, and discs. And these elements of passive, active, and neural control systems were outlined by Panjabi. I've modified them in some ways. So the passive system means the vertebra, discs, and ligaments. And they are highly responsive because the bones are really major forces and the ligaments of sending afferent signals into the nervous system. The position of each vertebra, the tension, the mechanical tension transduces information energy. Through the bones, you have the piezoelectric effect creating an induced field around the system. You have the vertebra, discs, and ligaments collectively function the passive subsystem. Why are they called passive? Because something has to move it. Now, the passive subsystem you may assess looking at an X-ray, looking at the vertebral alignment, looking at the degree of degeneration of the disc. You may look at the height of the disc as relative to hydration. Now remember, the way the disc gets into nutrition is through the movement through the vertebral end plate and through its osmosis of the end plate. And the ligaments don't just hold bones together. They also give abicanoreceptive, proprioceptive input into the nervous system, which also helps determine your tension level, your emotional level, where you are in space, your balance, and affects the emotional system, the sympathetic system. The active subsystem, this is the muscles and long tendons of the spine. And this really is called active because it moves bones. Muscles move bones. And it dissipates the tension through the large muscles, the postural muscles and tendons. The passive subsystem also does involve the small intervertebral muscles, which actually, and some of the anterior small muscles, which actually help lock the vertebra in this segmental position. The active subsystems deal with the large muscles, the postural muscles, and those are connected more into the visceral somatic pathways and into the balance mechanism, where the spinal intrinsics, the small muscles, are more hooked into the defensive, vertebrogenic defensive musculature, which puts the person into a survival mechanism rather than a response mechanism. The active subsystem is helping move bones and ligaments, and the range of motion you're seeing in a vertebra is the active system exerting its effect on the passive system. We may measure the passive system by its compliance. We use a palpation, applying for the vertebral compliance and looking at that. Also, when you feel the musculature, if there's not a pleural segmental discharge from several levels characteristic of the active subsystem facilitation, you may instead feel a general tension without facilitation over a broad area. That's most associated with the connective tissue intelligence and a challenge there. The passive subsystem is associated with the connective tissue and the bioenergetic intelligence. The active subsystem is associated with the emotional energetic intelligence, and the neurocontrol subsystem is more associated with the mental energetic intelligences. Those people who assess the active subsystem may more assess for the surface electromyograph or its relationship to the passive system or the postural elements. The third subsystem is the neurocontrol subsystem. The neural subsystem, according to Panjabi, is the brain and the spinal cord and the nerves. And it is actually relaying messages between the active and passive systems. So if you, for example, are in a car accident or have a fall or an accident, there's a signal from the vertebra, discs, and ligaments going from the passive system into the neural control system, and the response will be an active, adaptive response there. Now, the neural subsystem, instead of just having the vertebral ligaments and discs as a passive subsystem and connective tissue, or the muscles of the active system, I extend the neural subsystem to also include the relationship of the vertebra in the vertebral spinal cord in the vertebral column with the meninges. Now, there's an overlap there because the meninges also affect the passive subsystem, the connective tissue. But I am seeing that there's two aspects. There's a passive subsystem affecting the body connective tissue, and there's a passive subsystem affecting the mechanical tension also within the spinal cord of the neural canal. So the relationship of the meningeal system to the spinal cord is associated with the neural subsystem. The actual connective tissue tension in it is more associated with the passive subsystems. The connective tissue tension is more associated with the passive subsystem, and the actual relationship that is established in the neural subsystem in the general tension generated to the spinal cord is more the neural subsystem. That we monitor through the flexion extension and lateral bending, the two directions of adverse spinal cord tension. And the work of Alf Brigg really is a wonderful model. It matches the concepts that Palmer talked about in the 1920s about multiple spinal cord tensions, and the Brigg model of adverse spinal cord tension really looks at neural subsystem tension there. So when we see the neural subsystem tension, we rate it by the heel tension, resistant and flexion extension of the ankles moving up and down, or the eversion stress, the lateral bending of the ankles, because the tension from the spinal cord is transmitted to the tendons, and that's transmitted into ankles. So we're looking at those systems. And by the height, the place in the ankle the tension is, tells us whether indeed there's mechanical tension in the cervical spine or the sacrum. That doesn't necessarily tell us that's what we're going to address. We're going to say that's where the tension is. We will observe the ankle moving through its range of motion as indicative of the spinal cord moving up and down the neural canal. The neural subsystem may be assessed with thermography, which is more the sympathetic involvement of it. You could also check the neural subsystem in the regulation indirectly by the adrenal pituitary profile. It also could be checking the heart rate variability with this, EEG and coherency. I could also be checking for neural subsystems. I like the neural test, a basic test of a neurological test of the mechanical tension in the system. You know, when you learn about the Lesage and the Braggart and all the basic tests, they're really checking for tension somewhere between the brain and the dural sleeves as mechanisms of neural subsystem tension, but actually doing the test can sometimes not be so benign and actually cause damage. This is a really, really wonderful way of assessing flexibility with a neural subsystem. So you're in the garden now, and you're bending over doing gardening, and it's 2 hours. You go to straighten up, and suddenly you blow a disc, or you have tremendous pain and spasm. Why? It's because you had a loss of integrity of the spinal and neural integrity subsystems. What should happen theoretically is, as you're bending for a while, the passive system, if it's able to have enough energy moving through an information without bound energy in the system, it could signal information to the neural subsystem to start changing the way you move your body, etc. If you don't have a system there and you don't have effective coordination of energy and information, you're then prone to injury. You can actually predict the type of injury in what part of the body ahead of time by the effective coordination or lack of coordination in the subsystems. There's one more subsystem I add to this picture, one more player on the team that Punjabi doesn't speak about, and that is the emotional subsystem. Now, where the active and passive subsystems of spinal and neural integrity really are located in a particular place in space, the emotional system is a functional system. It's not really located in any particular space. Then where is it? Well, from a cellular level, if you have stretched a membrane of a cell, you alter its architecture, you alter the peptides that combine by it, that's altering the actual receptor sites. You're altering the emotions that can be expressed, because emotions are associated with binding sites of neuropeptides on the cell membrane. The same way, if you stretch the spinal cord in a certain way and spine in a certain posture, you predispose certain emotions at the expense of other emotions. So what I am saying is this: if the spinal or any tissue, the spinal cord, the ligaments, the discs, you have any organ, any tissue of the body, the connective tissue, does not move through its natural full range of motion, is limited in its oscillation, and oscillation is a communication in the system. If it's limited in its macroscopic or microscopic oscillation or macroscopic oscillation, which shows up as rhythmic movement, if it's limited in that, or it's limited in its range of tension, where it stays with one tension, then there's an alteration in emotion. So therefore, when you have adverse spinal cord tension in the system, it really is a distortion of the emotional subsystem. When you have active subsystem tension, where it's tension in a certain area with a fixation in posture, that's an alteration of the emotional subsystem. When you have fixation in vertebra, it's an alteration in the emotional subsystem. And the key thing to be aware of this, the emotional brain controls the threshold of excitability. Listen to this. The emotional brain controls the threshold of excitability of every sensory and motor fiber of the body. So that's important. So if tension is bound up in the emotional system, in the emotional brain, then it's going to alter the threshold of the active passive neural control system, the pain mechanism, and the stress response. So while we are not going to directly assess for the emotional subsystem, but we are indirectly going to see by a change of oscillation and distribution of energy and this range of motion that the emotional system is affected. And the way the emotional system actually dissipates tension is through rhythmic, according to Halsted, who talked about an additional motor system, that there's the voluntary muscle motor system, there's an autonomic or visceral motor system, and the third motor system is the emotional motor system. And Halsted actually speaks about that and says that the way it dissipates tension is by making sounds, vocalization, crying, maybe screaming, or maybe the sounds in vomiting, retching, screaming. It dissipates tension by rhythmic movements of trunk and extremities. Hence, the dissipation of tension from the neural system is associated with a network wave. So we start seeing those particular things, and now we can actually take a look at the rhythmic pulsation of the body. It also dissipates tension. What does it do? It dissipates it through the subsystems, and if they're functioning effectively, now the energy can be used as, instead of bound energy, work energy to reorganize the spine, consistent with its self-organizing nature of its wave. It's exquisite. And another way it does it is through facial expressions. Making facial expressions also dissipates the tension. So collectively, we'll be assessing in network every system, every visit, every contact, what's happening with the energy and information moving between the passive active neural control system, and at each level of care, the level of efficiency of coordinated oscillation gets more and more refined, more energy efficient, and is associated with higher levels of spinal reorganizational healing, and with that, a person's ability to access new resources in life and in healthcare. So the whole idea here is we're always dealing with external and internal stressors. All of that is always putting stress on the body. The spine is a transducer of the relationship of your internal and external environment. It is the modulator of function. It is a modulator of emotion. It is a modulator of the sense of self. It is a modulator of conscious actions and behaviors. It's a modulator of even spiritual experience. So spinal neural integrity at higher levels of complexity is the missing link in virtually every area of a person's life. And through NSA, not only will you learn to assess the system, and with different levels of care, higher and higher levels of effectiveness, you'll also be able to use that as a means of understanding what's going on in the person, in the body, in their life, and you'll use it as a means of determining the application each visit. Have fun, enjoy it. The key of network spinal analysis is the analysis part, and really mastering spinal neural integrity, its meaning, and what's happening each session is the key to mastery in the application of NSA as a chiropractic technique.